Good morning all. Welcome back to next lecture. Till now we have discussed the linear equation and its types. Especially the linear equation in one variable, the system of linear equation with the two variable and three variables and their various applications in economics. We discussed the application of linear equation in economics like demand and supply analysis, national income determination models, then ISLM model. Today we will discuss the quadratic equation. As we have already defined a quadratic equation earlier, that it is a non-linear equation. I hope you know what is the difference between linear and non-linear equation. See, linear equation and non-linear equation are differentiated by looking at their degree or their, what we can say, their linearity. The degree of variable in a linear equation is 1, as we are already defined and discussed in detail. It means that each variable appeared to have a power of 1 only. And this linear equation form a straight line when you go for plotting on a graph paper, which means that the graph of a linear equation is always a straight line. However, in the case of a non-linear equation, the degree of variable is greater than 1, which means that the variables may appear to the power like it is x square or maybe x cube or maybe x raised to the power 4. So a non-linear equation does not form a straight line as like in the case of a linear equation if you go for plotting on a graph paper. It may be in the form of curves, or it may be in the form of circles, or it may be parabola or other shapes. So here we will discuss the non-linear equation with the highest power of the variable being 2. That is a quadratic equation. See, the quadratic equation is an equation in which the highest power of the variable, that is for example x, or it is unknown variable, is 2, which is generally called a quadratic equation of the second degree, or it is quadratic or second degree of polynomial function. So that means a quadratic equation is a second degree polynomial equation, meaning the highest power of the variable is 2. If you consider the general form of a quadratic equation, then it will be in the form of ax square plus bx plus c, which is equal to 0, where a, b and c are the constant and a is not equal to 0. See, if a is becomes 0, then this entire term will goes to 0, then what is remaining? bx plus c. This equation will become a linear equation. So we are assuming here a is not equal to 0. Now consider one example. See, x square minus 5x plus 6, which is equal to 0. This is an example because here the unknown variable x, the power is equal to 2. So highest power of the variable is here, it is 2. So we can say that this is a quadratic equation. Now a quadratic equation may be a pure quadratic equation or maybe incomplete quadratic equation. See, a pure quadratic equation where we have complete terms, that means the equation in the form of ax square plus bx plus c is equal to 0, where a, b, c are the constant and a is not equal to 0. The highest power of x is here is equal to 2. As against the pure quadratic equation, we have incomplete quadratic equation as well. See, what do you mean by incomplete quadratic equation? This is the specific case of a quadratic equation. See, where the coefficient of linear term, see what is the coefficient of linear term? That is here it is b. The coefficient of linear term b is equal to 0. So if b is equal to 0, then bx will become 0. Then what is remaining here? It is ax square plus c, which is equal to 0, where b is assumed to be 0. So if the equation in the form of ax square plus c is equal to 0, then we can say that it is an incomplete quadratic equation. Now let us consider there are several methods for solving a quadratic equation, depending upon the specific form of an equation and your personal preferences. See, we have a methods like factoring method, we have a quadratic formula, we have a completing squares method, we have a graphical methods. See here, out of these methods, today we will focus only on the factoring method for solving the quadratic equation. And the factoring method is applicable, generally it is applicable when you can express the quadratic equation as a product of two binomials. If you are in a position to express the quadratic equation in the form of the product of two binomials, then generally we are using the factoring method for solving the quadratic equation, which means that this method is effective when the quadratic expression is factorable. The quadratic expression is factorable, then we are generally using the factorization method. Now, let us discuss what are the procedures to solve the quadratic equation by using factorization method. See, in the case of a factoring method, we are generally used to solve the quadratic equation by rewriting the equation as a product of two linear factors. For example, consider the quadratic equation in the form of ax square plus bx plus c, which is equal to 0. See, by using the factoring method, we can solve this particular equation. See here, first we want to find out the two numbers. We will find out two numbers. For example, we are denoting here these two numbers are m and n. And these two numbers are such a that their product is equal to a into c and their sum is equal to b. That means we are going to identify two numbers which is m and n whose product is equal to the coefficient of a and coefficient of c, that is a into c. And similar time, see their sum is equal to the coefficient of x, that is here it is b. So if this is in the form of, then we are able to express these variables in the form of a factors. So here once we find these two numbers, then we can rewrite the quadratic equation in the factored form, as just like we know it is x plus m into x plus n, which is equal to 0. So we can write in this particular format. Then you can solve for x by setting each equation is equal to 0. That means here x plus m is equal to 0, then x plus n is equal to 0. So once you have found the values of x, then that satisfy this equation, then those are generally considered as the solution for the quadratic equation. So these are the various procedures to find the solution for a quadratic function or quadratic equation by using factoring method. Let us consider one example so that it will be more clear. See, x square minus 5x plus 6 is equal to 0. This is a quadratic equation. Here a is equal to 1, coefficient of a is equal to 1, coefficient of b is equal to minus 5 and c is equal to 6. So in order to solve this particular quadratic equation using factoring method, we need to find two numbers whose product is 6 and their sum is minus 5. See, a into c, which is 1 into c, that is 6, which is equal to 6. So two numbers whose product is 6 and at the same time their sum is the coefficient of b, which is equal to minus 5. Let us try to express 6 as the product of two numbers. We will identify these numbers. See, we can say that two numbers may be 1 into 6. We may have 2 into 3. But at the same time, we should keep in mind, we should need to get the sum of minus 5. So if we are considering it is 1 into 6, then it is very difficult to get it is minus 5. See, if you are putting minus sign for the minus 6, then it will become, here it is minus 6. So it is not possible. So we are considering 2 and 3. 2 and 3 will be the possible factors. So here 2 and 3, again we want to change the sign. If you multiply 2 into 3, then it is 6. But if you add up, then it is 5. So we want minus 5. It may be minus 2 and 3, or it may be 2 minus 3. Minus 2 minus 3 will be proper, so that we will get minus 5. And if you go for multiplying minus 2 into minus 3, you will get a plus 6. So now we can rewrite the middle term, that is minus 5x with these two factors. So it will be equal to, see, instead of minus 5x, I am writing here it is minus 2x and minus 3x. So the midterm I have replaced, that is minus 5x I have replaced with minus 2x minus 3x. So now we can group these terms. See, like x square minus 2x we are grouping into 1, then minus 3x plus 6 which we are grouping here another term. So we have two terms here, it is x square minus 2x plus minus 3x plus 6 which is equal to 0. See, now here there is a common term, it is x is common here. So I am taking x is outside, then what is remaining? It is x minus 2. Here it is 3 is common, so I am taking here minus 3. So it will be minus 3, then what is remaining here? It is x minus 2 which is equal to 0. Now see here, x minus 2 is common here, so I am considering only once. Then what is remaining? X minus 3. So here the factors are x minus 3 into x minus 2 which is equal to 0. Now according to this zero product property, we can equate these terms into 0. So x minus 3 is equal to 0, x minus 2 is equal to 0. Now you can solve for x is equal to it is 3 and x is equal to it is 2. So here the values for the x as per the factorization method, the x is equal to 3 and x is equal to 2. So in this way we can solve the quadratic equation by using the factorization method. Consider another example. See, x square plus 3x plus 2 is equal to 0. So now here a is equal to 1, b is equal to 3 and c is equal to 2. So now we want to solve this equation for by using factorization method. We want to find out two numbers whose product is 1 into 2, that is 2, and whose sum is the term of b, that is 3. So accordingly we can identify, it may be the numbers like the pair of numbers whose product may be 2, which is 1 and 2. So it is of course only 1 and 2 is there. So at the same time if you go for adding up these two terms, you will get 3. So 1 and 2 will be the numbers, and accordingly I am replacing the second term, that is 3x, in terms of 1 and 2. So here I can rewrite the term 3x in terms of x plus 2x, because the 1 into x which is equal to x plus 2 into x which is equal to 2x plus 2 is equal to 0. Now I am grouping these terms, that is x square plus x is a one term and 2x plus 2 is equal to another term. Now here x is common element, so I am taking outside. What is remaining here? X plus 1, x into x plus 1. Here 2 is common, so I am taking into the outside. Then what is remaining here? It is x. Then here it is only 1. Now see, this is the format, x into x plus 1 plus 2 into x plus 1 is equal to 0. See here, x plus 1 and x plus 1 is common here. So I am taking only 1 x plus 1. Then what is remaining here? X plus 2. So the factors are here x plus 1 plus x plus 2 which is equal to 0. Now we can equate each term equal to 0. See, x plus 1 is equal to 0, x plus 2 is equal to 0. Then I can solve this equation for x, then x is equal to minus 1 and x is equal to minus 2. So here the value of x is equal to minus 1 and minus 2. Now let us consider another example. See, it is x square minus 16x plus 48. So we need to find out the two numbers whose product is 48 and whose sum is minus 16. So these are the numbers which may be 148, 224, then 316, 412 and 6 and 8. These are the possible numbers whose product is equal to 48. Now among these, we want to get those pair whose sum is equal to minus 16. So I am considering here, see, it will be possibly it is 4 and 12. 4 and 12 we are going to consider. So here I am taking minus 4 and minus 12, so that it will become minus 16. And if you go for multiplying minus 4 into minus 12, which is equal to 48. So now I am replacing minus 16x with 4 and 12. So it will be minus 12x minus 4x plus 48. So now we are grouping these two terms. See, x square minus 12x, one term, then minus 4x plus 48 is the another term. So here then equating with the 0. So what is common here? It is x is common. So taking x into the outside, what is remaining here? It is x minus 12. Here minus 4 is common, so I am taking minus 4 outside. Then minus 4 into what is remaining here, it is x minus 12, so that it will become plus 48, which is equal to 0. Now x minus 12 and x minus 12 is common here, so I am taking only one x minus 2. Then what is remaining here? It is x minus 4. So factors are here x minus 4 and x minus 12, which is equal to 0. So now I am equating each term with 0, then x minus 4 is equal to 0, x minus 12 is equal to 0. Then solving for the x, then x is equal to 4 and x is equal to 12. So this is the solution, that is x is equal to 4 and x is equal to 12. Now I am going to take the another example. See here, it is little bit different from the earlier cases. Till now what we discussed, the example of a quadratic equation where the coefficient of x square was 1. But now see, the given example, the coefficient of x square is equal to 4. So in order to solve this equation using the factorization method, we want to find out two numbers whose product is equal to, see, AC, that is 4 into 9, which is equal to 36. And then we want to list out what are the various numbers or number pairs which will give you 36. See, it may be 1 into 36, which may be 2 into 18, which may be 3 into 12, or it may be 4 into 9. And out of here, see, if you consider here, then all these will give the product of, 36, and sum should be, it is 15. So I think that it is the better number, that is 3, 12. The plus sign will be remaining. So if you multiply these two terms, you will get the 36, and if you add up, then you will get 15x. So now we are going to replace this 15x with these two numbers. So it will become, see, instead of 15x, I am substituting here 3x plus 12x. So it is 3x plus 12x, which is equal to 15x. Now I am grouping these two terms, that is 4x square plus 3x plus 12x plus 9. See here what is common? Here x is common, so I am taking x into the outside. Then what is remaining here? It is 4x plus 3. Here 3 is common, so taking outside here. Then remaining here it is 12x plus 3, which is equal to 0. So here we have 4x plus 3. 4x plus 3 is common, so I am taking only one 4x plus 3. And what is remaining here? It is x plus 3. So I am taking x plus 3 and 4x plus 3, which is equal to 0. Now I am equating each term with 0, then it will become 4x plus 3 is equal to 0, x plus 3 is equal to 0. So if you solve for x, then 4x is equal to minus 3 and x is equal to minus 3 by 4, dividing the both sides of the equation by using 4. Here x is equal to minus 3, here x is equal to minus 3. So solution we have here, x is equal to minus 3 by 4 and x is equal to minus 3. Now let us consider another example with the same coefficient of x square is equal to 6. See, again here we want to find out two numbers whose product is equal to a into c, that is 6 into minus 2, which is equal to minus 12. Then we will list the numbers which will give minus 12. Sorry, this is not 36, it is minus 12. So minus 12 will be considered. So what are the various factors? Which will be 1, 12, 2 and 6, which may be 3, minus 4 or 3 into 4. Then out of this, see, we are considering 1 and 12, so that we should get a minus 1 if you go for considering the sum. So here it is better to consider it is 3 and 4. 3 and 4 is the which will give you the sum of minus 1. So here we are putting 3 minus 4. See, 4 is minus, so that we will get minus 1. So if you add up these two terms, then you will get minus 1. And if you multiply these two, then you will get minus 12. So here I am going to replace minus x in terms of 3 and minus 4. So here it is 6x square plus, instead of minus x, it is 3x minus 4x minus 2 is equal to 0. Now after that we are grouping here. So 6x square plus 3x minus 4x plus 2. Minus is considered here, so it is plus sign here. Then what is common here? It is 3x is common here, so I am taking 3x into the outside. So then what is remaining here? It is 2x plus 1 minus 2 is common here, so taking 2 into the outside. Then 2x plus 1, which is equal to 0. Now 2x1, 2x plus 1, 2x plus 1 is common here, so I am taking only 1 2x plus 1. What is remaining? 3x minus 2. So 3x minus 2 and 2x plus 1, which is equal to 0. So these are the two factors. Now I am equating these two factors separately to 0. So 2x plus 1 is equal to 0. 3x minus 2 is equal to 0. So I am now solving for x. So 2x is equal to minus 1. 3x is equal to 2. So x is equal to dividing the both side with 2. Then it will become minus 1 by 2. Here dividing the both side by 3. Then you will get x is equal to 2 by 3. So here the x is equal to minus 1 by 2 and x is equal to 2 by 3. Now we have another question. See here, y raised to the power 4 minus 5y square plus 6 is equal to 0. See, this is not a quadratic equation. This is a quartic equation because the highest power of the unknown variable here, it is y is equal to 4. So this type of equation is generally known as it is quartic equation. But we can convert this quartic equation into the quadratic equation. That means we can treat it as a quadratic equation in terms of, assuming y square is equal to x. If you are assuming y square is equal to x, then this equation will become, see, instead of y square we are putting x. Then we can write y raised to the power 4 is equal to x square minus, instead of 5y square is equal to x. So I am writing it is minus 5x plus 6 is equal to 0. So now our equation is in the quadratic format or quadratic equation format. Now you can use the factorization method here. See, the coefficient of x square is equal to 1. So our product of two numbers, that is equal to 6, and sum is equal to minus 5. So accordingly the factors numbers may be 1, 6, 2, 3. So out of this I think that the answer will give you, it is minus 2 minus 3, which will provide you, minus 5, and if you multiply these two numbers then it will get 6. So instead of minus 5x I am here writing minus 2 and minus 3. So it will become minus 2x minus 3x plus 6 is equal to 0. Now we are grouping these terms x square minus 2x separately and minus 3x plus 6 separately. So we have a x square minus 2x plus minus 3x plus 6 is equal to 0. Now we are taking one of the common element here. It is x is common, so I am taking into the outside. What is remaining? X minus 2. Here minus 3 is common, so I am taking minus 3 into the outside. What is remaining? It is x minus 2. So it will minus 3 into minus 2, it will become plus 6. So equating to 0. Now x minus 2 is common, so I am taking only one x minus 2, then x minus 3 also here. So it is x minus 3, x minus 2, which is equal to 0. Now separately I am equating these terms to 0. So x minus 3 is equal to 0, x minus 2 is equal to 0. So now solving for x, then x is equal to, it is 3 and x is equal to, it is 2. Okay. Now the values are here, and x is equal to 3 and x is equal to 2. So in this way you can find out the value of x, but this value of x is equal to y square. Now we want to convert it, because since y square is equal to x, the y can be find out by taking the root. So by taking the root, x is equal to 3. So y square is equal to, y is equal to plus or minus root 3. It is not y square, it is y is equal to plus or minus root 3. Similarly, when x is equal to 2, then y is equal to, it is not y square again, it is wrongly written here, it is y, then y is equal to, it is plus or minus root 2. So in this way, we can convert the x into y. So accordingly, we can solve the quadratic equation in the form of a quadratic equation. Now we have a last question. See, the marginal cost of a firm under perfect competition market is given. That is marginal cost, that is MC is equal to, marginal cost is equal to q square minus 8x minus 1. And if the market price is already fixed, because we are assuming a perfect competition market, so we have a market price which is equal to 19 per unit, 19 rupees per unit. And we want to find out the equilibrium level of output, that is we want to find out the value of Q. See here, the marginal cost is given, that is Q square minus 8Q minus 1, and the price is equal to 16. See here, what is the market situation? It is the perfect competition market. Under the perfect competition market, a firm is in an equilibrium when MR is equal to MC, where MR is also equal to, of course it is AR, which is also equal to the price. So under equilibrium, MR is equal to MC, where MR is equal to AR, which is also equal to the price. So MC and MR can be equated here. So we can equate here MC under perfect competition market. See, firm is an equilibrium when MC is equal to MR, which is also equal to the price, because we are assumed here under perfect competition market situation. So we can equate here the marginal cost directly with the price level. So MC here it is Q square minus 8Q minus 1, which is equal to 19. 19 is price. So this is the equilibrium condition under perfect competition market. If you solve it or simplify it, then we can write by taking plus 19 into the left side, so it will be minus 19. So minus 19 minus 1, which is equal to minus 20, and we are equating with 0. So now here we have the term that is Q square minus 8Q minus 20. See, this is nothing but this is a quadratic equation. Instead of variable x or y, here we are using the variable unknown variable is equal to Q. Now we can find out those number, that is A into C, which is minus 20, whose product is minus 20 and whose sum is minus 8. We can find the number which may be 120, which may be 210. So this number will be provided here, 210. If you multiply the 2 and 10, then you will get 20. So we want minus. So here we will put, it is better to put the minus sign for 10, so that we will get minus 8. So I am putting here, considering here, plus 2 and minus 10. So we are considering here it is minus 2 and minus 10 and plus 2. So here Q square minus, instead of 8Q, here I am writing it is minus 10Q plus 2Q, because these are the two numbers here, minus 10 and plus 2. So it is minus 10Q plus 2Q minus 20 is equal to 0. So now we are grouping this equation. See, Q square minus 10Q plus 2Q minus 20. So which is equal to 0. Now what is common here? Q is common, so I am taking Q into the outside. So Q into Q minus 10 plus, what is common here? It is 2 is common here. So it is 2 into Q minus 10. So that it is 2 into 10 will provide you, it is minus 10 which will provide you minus 20, which is equal to 0. So now the Q minus 10 and Q minus 10 is common. So we are considering only one Q minus 10. Then we have Q plus 2. So our factors will be Q plus 2 and Q minus 10, which is equal to 0. So here Q plus 2, Q minus 10 is equal to 0. We are separately equating these two terms to 0. So Q plus 2 is equal to 0 and Q minus 10 is equal to 0. So here we can solve this equation for we can solve this equation for Q. So Q is equal to, it is minus 2, here Q is equal to 10. Now see, what do you mean by Q? Q is the level of output. So minus 2, which does not create any meaning in economics. So minus 2 output, which does not create any meaning here. So we are considering Q is equal to 10, because since output is not negative, that is minus 2, we are not going to consider. Rather, we are going to consider Q is equal to 10. So the equilibrium level of output is equal to here, it is 10. So let me conclude here. See, we have discussed today the factoring method for solving the quadratic equation. And I hope it was clear to you. In the next lecture, we will discuss another method for solving the quadratic equation. We will see in the next lecture. Thank you.